Hello students, this is Callie Daniels, and in this video we will solve linear equations using both properties of equality. So our steps for doing so are: step 1, we'll simplify each side separately. Use the distributive property to clear parentheses, decimals, or fractions, and then combine like terms. In step 2, we will isolate the variable term on one side. To do this, we use the addition property of equality so that the variable term is on one side of the equation and a number is on the other. Step 3, let's isolate the variable. Use the multiplication property now, if necessary, to get the equation in the form of x equal a number. And our last step, this is always good to check. Substitute your proposed solution into the original, that's the first equation. If a true statement results, write the solution set. If not, then go back and rework the problem and look for any errors that you might have made. Well, let's practice these steps. Example 1, use the 4 steps to solve each equation. All right, so here we go. We're going to simplify each side. I'm going to use the distributive property. 5 times 2m is 10m. Got a plus sign in the middle, and 5 times 3 is 15. And just write the rest of your equation. Minus 4m is equal to 8m plus 27. Now let's combine like terms on the left-hand side. 10m minus 4m is 6m. So 6m plus 15 is equal to 8m plus 27. So step 1 is complete. We've simplified each side. Now we're going to move our variable term to one side, the numbers to the other, and here we use our addition property of equality. Just remember to do the same thing to both sides. I'm going to go ahead and move my variable terms to the right and the number terms to the left. So we're going to do this in one step. So to move 6m to the right, we're going to do the opposite, or add the opposite. We're going to add a negative 6m, or you might say subtract 6m. Be sure to do that from both sides. Okay. Now, as an end result, it's going to cancel our m term off the left, move it to the right. 8m minus 6m is 2m. At the same step, I'm going to move the number terms to the left. So let's do that by looking at plus 27 and adding the opposite, or doing the opposite, subtracting 27 from each side. It's going to cancel our number term off the right-hand side, move it to the left, and 15 minus 27, that's going to be a negative 12. Step 2 is complete. We've used the addition property to isolate our variable term on the right-hand side. Last, we're going to use our multiplication property, or in this case, we'll use a division step. To get m by itself, let's divide each side by the coefficient 2. We know that 2 divided by itself is 1. That leaves 1m, and go ahead and divide on the left. Negative 12 divided by 2 is negative 6. And always be sure to check that in your original equation. This one is going to check out, so I'm going to say the solution set is negative 6. Let's look at part B. 4x plus 9 is equal to 3 minus, in parentheses, x minus 2. So we're going to simplify on the right-hand side. Again, let's use our distributive property. Here we're just distributing a minus symbol to both the terms that follow it. So it becomes minus x minus the negative 2 is plus 2. Let's combine like terms on the right. I'm going to write my negative x term first. 3 plus 2 is 5. Okay, so now we're ready to use our addition property of equality. This time I'm going to move the x terms to the left and the number terms to the right. Now you'll get to the point where you don't have to write this down. You'll be able to do it in your head, okay? But I'm going to go ahead and write it down again. I'm going to add x to each side. I'm just penciling in and keeping this equation balanced. X is going to cancel off the right-hand side. On the left, we've got 5x. Now let's move our number terms to the right. The opposite of adding 9 is subtracting 9. So let's subtract 9 from each side. That's going to move that term to the right, and 5 minus 9 is -4. Now as the last step, our multiplication property, but again I'm going to think in terms of division. Let's divide each side by 5. Now we've got x is equal to -4/5. That fraction does not reduce, so it's in a decent form. And again, you can check it if you want in your original equation. It will check. You will get a true statement when you substitute that. Our solution set is -4/5. Now let's turn the page here and look at example 2. Here we want to solve each equation, determine whether it has no solution or infinitely many solutions. So something rather unique will happen with these equations. Let's see what that is. As we simplify part A on the left and distribute the 3. 3 times 6 is 18 minus 3 times 4x, so that's going to be a minus 12x. On the right-hand side, distributing the 2, we have minus 12x and plus 18. And right about now, do you see that our two sides are identical? We've got a term called positive 18 on each side. We've got a term called negative 12x on each side. This, we say, is an identity. Both sides are identical, aren't they? And anytime that you see this, if we continue our steps of trying to isolate our variable on one side and the numbers on the other, notice what happens. So let's say that we want to add 12x to each side. Well, what happens? That 12x disappears off both sides, doesn't it? Okay, and that leaves us with the statement 18 is equal to 18. Or you might say, well, I'm going to subtract 18 from each side. Well, that leaves the true statement 0 is equal to 0. So regardless what happens here, your variable term is going to disappear in an identity, and you're going to be left with a true statement, whether it looks like 18 equal 18 or 0 equals 0. And what we say about this one is that our solution set is all real numbers. All real numbers, because any real number that we substitute into this equation is going to make it a true statement. And we can see that that's going to happen right here in this step. That's the identity. Now, I know that we should always check in the original equation, but I just want to show you something here, okay? As we look at this step right here, just think about, what would happen if we substituted x equals 0? Well, we would have 18 minus 12 times 0 is equal to negative 12 times 0 plus 18. And we can see that that's a true statement. 18 is equal to 18. What if you substituted x equal 1? What if x is equal to 1? Well, we're going to get a true statement again, because 18 minus 12 times 1 is equal to minus 12 times 1 plus 18. Okay, both sides are essentially 18 minus 12, or -4. So we're always going to get a true statement no matter what number we substitute into that identity. Therefore, solution set, all real numbers. Now, part B is related, but you're going to see something different happen here. Well, let's clean it up. Distribute the 6. That gives 12x plus 48. Okay, what do we have on the right-hand side? 12x. Yep. Oh, but minus 24. This is not an identity. We don't have exactly the same terms on both sides, do we? Okay. If you tried to move your x terms to one side, let's say you want to subtract 12x from each side, notice what happens here. Our x terms are eliminated, okay, off both sides. But this time we've got the statement 48 is equal to negative 12, okay? Excuse me, I don't know why I wrote negative 12, okay? 48 is equal to negative 24. I don't know where that came from. Just made it up out of my head. Hey, don't do that, okay? 48 equal negative 24. Well, that's a false statement, isn't it? Okay, so comparing to part A, variable disappeared, leaving a true statement. Part B, variable disappeared, it was eliminated, we have a false statement. Okay, and what we say to this one is that the solution set is the empty set. Okay, this symbol, a 0 with a slash through it, is the empty set symbol. The empty set. Let's write that down, make a note, okay? Okay. In other words, there is no solution. Okay, and you might try to substitute any numbers that you want to try, but we can see that, you know, on each side, if we multiply a number by 12 and then add 48 on the left and subtract 24 on the right, that's never going to be a true statement, is it? Okay, so solution set there is no solution. I always say that's the empty set. All right, students, here we've looked at examples where we simplified both sides, and then we went about solving the equations, and good luck on those.